Let me tell you the story of Anne Boleyn. Born in England around 1501, she rose to prominence, reaching the court in 1522. There, she met King Henry VIII, who instantly fell in love with her and eventually proposed marriage. Anne ascended to the throne, gradually gaining more power, which aroused the monarch's suspicions. However, their relationship began to deteriorate due to her miscarriages, the inability to produce a male heir, and her constant liaisons with other ladies. This worsened their relationship, leading King Henry to a decision. He had to dispose of her. Accusing her of adultery, she was executed, and her head rolled on the green floor of the Tower of London. However, the story doesn't end there. Legend says that even today, her ghost, head under her arm, roams the Green Tower of London, where she was executed. Since her death in 1536, a total of 30,000 sightings have been reported, always appearing the same, her ghostly decapitated body holding her head in her arms. Ghosts are one of the most widespread, studied, and present paranormal phenomena in our culture. But today, we're not looking at them through the lens of the paranormal, but through science to ask if it makes any sense. Could we have a ghost in our world? What does physics say? The internet is rife with ghost stories, tales that attract attention by blending terror with curiosity about the unknown and the hope of eternal life. These stories can be analyzed from many angles, including scientifically, to question their physical feasibility and what ghosts might be made of. We'll start by trying to define a ghost. According to these stories, a ghost is a kind of non-physical, intangible, non-interactive presence that contains the essence, memories, and character of a previously living person, sometimes even maintaining their appearance. Keep these details in mind for our scientific investigation. A scientist, in the absence of strong evidence, can only hypothesize about phenomena compatible with these characteristics. We talk about a presence that, in some cases, can be seen, but doesn't interact with its surroundings and maintains the essence of the person in life. Let's proceed like detectives, examining the most feasible story, which is basically a scientist's job. Let's start by exploring all the possibilities we can discard. We turn to what we know about matter and its composition in the universe. A peculiar Russian scientist gave us this tool, the famous periodic table of elements. These elements, known as atoms, were later found to be not the ultimate constituents of matter. Atoms can be split into smaller particles, protons, neutrons, and electrons. A few decades ago, it was discovered that protons and neutrons could be further split into even smaller particles called quarks. These particles, along with their heavier counterparts that exist but don't form matter because they're unstable, form what's known as the standard model of particle physics, with two families, quarks and electrons. Is there anything in this table that could form the material of a ghost? The simple answer is no. These particles interact with those around them and with light, so any substance made from these particles would be visible and tangible. We must discard this idea. The standard model particles can't form ghosts. But let's not lose hope and continue our investigation. The universe is much richer than this. If you know some physics, you might say this table is incomplete, and you'd be right. We've left out neutrinos, a particle related to the electron but without charge and almost no mass. Neutrinos are interesting because they fulfill two important requirements for ghostly matter: invisibility and non-interaction with ordinary matter. However, neutrinos don't interact with anything, not even themselves, meaning they can't form structures or complex entities like a body. Also, they have little mass and travel at speeds near the speed of light, so they're not suitable for forming ghosts. So, what else does the standard model offer? Remembering other components like bosons, like photons, gluons, or electroweak bosons, which are force-carrying particles and don't form matter, we find they're not suitable either. But photons give us an idea. What if, upon dying, we don't generate a tangible body but instead leave our essence, memories, and thoughts as energy? This idea is intriguing because although energy is an abstract concept, it exists but isn't tangible. You can't touch kinetic energy, just like ghosts. Energy, though intangible, interacts with matter and could theoretically carry information, like memories from life to death, transforming matter into energy. Could ghosts then be beings of pure energy? Upon closer analysis, this theory faces serious problems. Energy is a simple form of existence in the universe. How could it then form thoughts, which require complex structures? Also, how would this energy avoid dissipating? The second law of thermodynamics states that entropy always increases, meaning any energy source, be it kinetic or potential, tends to become simpler and more homogeneous, like heat. This is a big problem because any localized energy source would eventually disperse into heat, losing whatever kept it in a particular state. Moreover, a ghost made of pure energy would require an external energy source, like a combustion engine or nuclear energy, to prevent its energy from dissipating. And if ghosts are a form of energy, they should be measurable and leave traces detectable by particle physics. But no such traces have been observed, even in the most powerful collisions like those at the LHC or in astronomical observations. This leads us to conclude that such a form of energy doesn't exist. So, we've explored the standard model of particles, but is this the end of our search? Not necessarily, because we can explore possibilities outside the standard model, which we know is incomplete. One speculative idea in physics is the existence of parallel dimensions beyond our perception. We live in a three-dimensional world, but could there be more dimensions? Theories like string theory propose many dimensions in the universe. Could ghosts exist in another dimension and somehow manifest in our physical space? Unfortunately, this presents serious problems. Various measures in physics suggest we live in a three-dimensional world, no more. The only possibility is that these dimensions are very, very small and curled up on themselves, as proposed by string theory. But this doesn't offer much room for the existence of ghosts. What about parallel universes? This idea, proposed by theories like eternal chaotic inflation, the many worlds interpretation of quantum theory, or string theory, suggests the existence of physical spaces disconnected from ours. But beings from a parallel universe wouldn't be able to physically affect our universe, so this idea must also be discarded. The last wild idea is that ghosts could be made of dark matter. Dark matter is a type of matter detected by humans only through its gravitational effects. It has mass but doesn't interact with light, making it essentially transparent. Could ghosts be made of dark matter particles like axions or supersymmetric particles? Dark matter doesn't interact with ordinary matter, so it could pass through walls and be invisible. However, like neutrinos, dark matter doesn't interact with itself, so it can't form complex structures like spirits or ghosts. A fascinating proposal by physicist Lisa Randall suggests that imagining dark matter as a single type of simple particle is overly simplistic. Why couldn't there be a whole family of dark matter particles, similar to the standard model, with dark forces bending these particles together? This could allow for the coexistence of parallel worlds of dark and ordinary matter, but this hypothesis faces challenges, especially in transferring memories and experiences from ordinary matter to dark matter. Also, the conversion of matter to energy and then to dark matter upon death is a complex process, with no known physical mechanism. Plus, if ghosts were made of dark matter, they couldn't be seen or heard in our world. So, after a thorough investigation, it seems there's no simple way to accommodate ghosts within the material world or current physics. But could there be something beyond our understanding? That remains unknown and perhaps a discovery for the future.